5-3 and 5-4. Take 2. All right. So it's estimated that 45% of college students will participate in the club this year. A class of 30 students found the following probabilities. All 30 will participate. That's 0.45 raised to the 30th power. Now, in order for you to get that answer, you'd have to use the calculator. So you're going to do 0.45 I can let you bring me down. Raised to the 30th. I know you're trying. I'm not going to let it happen. 0.45 raised to the 30th. Enter. Now, what do you type into? What do you write on your screen? Well, Tori has already said, I think it's ridiculous if we have to put 0.00000000000 like a bunch of times. I agree, Tori. So what you should probably do is just take a picture of the screen and then just paste it. Like that. Now, she says you can't do that on the test. That's your problem. That's not my problem. So now you have anger management issues. Okay? No, on the test, what could you do? You could just put down 3.9 e to the negative 11. So if you wrote down the answer and you said, hey, this is 3.9 e to the negative 11, I know what you're talking about. Okay, if you want to be mathematical, you say 3.9 times 10 to the negative 11. That even makes you look smarter. Okay, if you want to look bored, you go like this: 0.000000039. Okay, count 10 spaces. All right. All right. What's the probability that none of the students will participate? That's 0.55 to the 30th. That's 0.55 to the 30th. Again, that's going to be a little bit better than the other one was. 0.55 raised to, use the caret key, the 30th. See, look, that's a lot better. Okay. Okay. What's the probability that exactly 20 people will participate? That is 30 choose 20, 0.45 to the 20th, 0.55 to the 10th. To type that in, it looked like this. What's wrong? 30 choose 20, 0.45 to the 20th, 0.55 to the 10th. Bless you. 0.009. Now, one of the things that people ask me is, do I do 0.009? Do I do 0.088? What do you want me to put? Show your work. I don't care near as much about rounding when I see your work as I do when I don't see your work. Please hear that again. Show your work. I don't care as much about rounding when you do that as I do when you don't. Okay? Now, more than 26. More than 26 means 27, 28, 29, or 30. That's what more than 26 means. Somebody in a different class one time said, no, more than 26 means 27. No, you could be more than 26 and be 28. Okay? So you got to do 27, 28, 29, and 30. So what's that going to look like? 30 choose 27, 0.45 to the 27th, 0.55 to the 3rd. 30 choose 28, 0.45 to the 28th, 0.55 to the 2nd. 30 choose 29, 0.45 to the 29th, 0.55 to the 1st, plus 0.45 to the 30th. Now you'll notice here that's four things, right? There's 27, there's 28, there's 29, and why am I pointing to the screen like you can see me pointing at it? I don't really know, but I'm pointing at them, okay? 27, 28, 29, 27, 28, 29, and 30. Okay? Now, this is the one I'm interested in. I just like drawing little arrows. That's the one I'm interested in. This one right there. That one. People will say, well, why didn't you do 30 choose 30? Why did you do 30 choose 27, 30 choose 28, 30 choose 29, and then you just decided to quit? 30 choose 30 is 1. How many ways can you choose 30 objects if you have to choose 30 of them at a time? 1. Okay? And then 0.55 to the 0, well, that would be 1 as well. So that's the reason why. Okay. All right. Now, what's the mean number that will participate? That is n times p. So the average is n times p. So in this case, it's 30 times 0.45. So you're going to go 30 times 0.45. That's 13.5, so that's the average. And what's the standard deviation? For those of you that can't see it, I'll move it down some. The standard deviation, you don't know this, but I'm telling you it now, is the square root of, bless you, n times p times q. So this is the square root of 30 times 0.45 times 0.55. Okay. So it's 2.72. All right, any questions on that? Going once? Going twice? Yes. P is the probability of success. That's 45% in this case. Q would be the alternative. So if it's 45% of the people will, 55% will not. Okay? So Q is equal to 1 minus P.
Would that be the standard deviation for any problem?
For any binomial, yes. The question is that the standard deviation for all binomials? The answer is yes. Okay. Q is the alternative. It's 1 minus P. It's called the complement. Okay. All right. With that being